Hi. I'm Matthew. I am a conversational user interface created by the authors of this paper.
Alrighty, Derek. I think I'm going to try and make an elephant, yeah? Kind of Tetris elephant.
Oh, yes.
So there's a piece that's like a L shape.
Mm-hmm.
Yeah, where, one piece is longer than the other. It's like
one?
about 4 units by 2 units.
Yeah, so you can't see it when I'm moving it here.
No, I just see the solution, yeah. I'm looking at an elephant, believe it or not. Okay, so it's like we're going to make the back leg. The bottom right of the grid.
We first looked at a corpus with human speakers teaching each other how to build a task with pentominoes. We then modeled the instructions constructed by the humans and synthesized them through a conversational user interface. Humans instruct each other with messy, disfluent, and incomplete utterances, packing instructions into pieces of information, known as installments. We then built a web interface to evaluate the fitness of each installment. Information was incrementally added to instructions provided by conversational user interfaces. While the agents were instructing users, we extracted their behavior from mouse movements to model how certain they were when making decisions. We also evaluated each instruction by extracting its semantic representation using BERT. The first user study demonstrated that adaptation in the form of installments is necessary. We asked users to tell us how much information each instruction had, and we found that some users required more information than others. People perceived differently the amount of information heard, and this was dependent on task accuracy, but also user uncertainty demonstrated in mouse movements. We extracted features that represent user uncertainty from mouse movement data to train adaptive instruction models. Utilizing mouse movements as a proxy of attention, we deployed 3 computational models into conversational user interfaces that detect user uncertainty and adjust instructions incrementally. The main idea is to predict in real time whether users will make a mistake and adjust the amount of information heard to their needs. We evaluated the machine learning models in a perception study. We compared speaker-based to listener-based models and found that interfaces eliciting linguistic adaptations were favored by users. The system automatically determined users' attention by utilizing their mouse movements, which defined the listener-based model. It also evaluated its own instructions for fitness, which we used to develop the speaker-based model. The system was able to predict in real time whether users will successfully complete the task and adjust how instructions are produced in an incremental manner. Next shape is. You need to find one that looks like a backwards S. With a piece coming of top right. Not this one? Zigzagging up. Yup, just like the very left of the puzzle. Great. That was correct. The system here monitors the user's behavior and makes decisions in real time whether to issue additional information and provide feedback. The type of adaptation that is required is one of the fundamental forms of social intelligence. It should not under-assist, as with too little information, the user will fail. It should not over-assist either, too much information may be overwhelming. Somewhere in between is the just right level of assistance that this user requires. In this paper, we designed a system that can adapt to the user's information needs by providing referential information incrementally. Our findings indicate that interfaces utilizing instructions incrementally can minimize collaborative effort with users. This work also yields novel insights into how mouse movements provide a reliable source for evidence of understanding. It also presents a methodological framework for adaptive interactive systems constructing instructions incrementally.